We'd like to welcome you to the Sustainability Fellowship Program reception. Today, it is my honor and privilege to introduce you to three outstanding fellows who have completed their work, their fellowship program, and we will be hearing from them shortly. Before we get started, I do want to cover the agenda and share with you that these three students are working on some wonderful work. Simi Chowdhury is working on the impact of organizational citizenship behavior on corporate sustainability through the mediating effect of total quality management. Ms. Claudia Aleman is a student from our College of Engineering who has done a report on the impact of COVID-19 on the campus carbon footprint at Utrgv. And we will also be hearing from Eric Martinez, who has created a flow simulation for a novel wave energy converter design. These presentations are pre-recorded, and so we will hear all three presentations, and afterwards we will open up for Q&A and comments. But before we get started, I would like to allow Dr. Parwinder Grewal, our leader and #1 supporter for this fellowship. He helped establish this program, so we're going to hear from him as he provides us our welcoming remarks.
Thank you, Ms. Franklin, for this event today. I'm very, very excited to hear about these presentations from these outstanding fellows. I'm glad that we are able to provide some support for their work. And this type of work, as I might have said before, is so important to the continuation or sustainability of the entire civilization and our planet. And the small contributions that every student, every faculty member makes goes a long way. So I'm excited to hear what they have to say, and I will make my remarks after I hear their presentations a little bit later.
Thank you, Dr. Grewal. I do want to share with everyone that this program was also established in alignment with the strategic plan for the university, whose core priority is to provide student success. Within that, some of the tools to provide student success is the element of sustainable development. And so we're really excited that this program has had such success. It is in its third year now, and we have had many sustainability fellows come through the program and are showing much success within their graduate programs. So we want to also share with you that we align sustainability at Utrgv with the United Nations 17 Goals for Sustainable Development. You're going to hear and see a little bit more about these goals as the students present. So we ask our students to consider which of these goals they are contributing to through their work, through their research, through their projects. And they are asked to specifically and intentionally bring forth the research that proves that their projects are actually sustainable. In other words, that they have a beneficial impact to society, to the economy, and the environment. Not one of the three, but all three. So the students take a lot of time and effort to collect data, qualitative and quantitative data, to actually show the intention of sustainable development, to show the intention of sustainability within their work, regardless of discipline. So today you will have the opportunity to hear from three outstanding students, remarkable work, very inspirational. And we're going to begin with Ms. Simi Chowdhury. Ms. Simi is from the College of Business, and her work is on the impact of organizational citizen behavior, which is called OCB, on corporate sustainability through the mediating effect of total quality management, which is called TQM. You will hear these acronyms throughout her presentation. She has been advised by Dr. Zhu Zheng, and we're really, really proud of her work. She's done an excellent job. And so I'm going to let Davy share the presentation. Again, these are pre-recorded presentations. I also want to share that Ms. Simi and our next presenter, Ms. Claudia, will not be with us for Q&A because they are actually taking a final exam at this moment. But I believe their advisors are with us in case anyone has any questions or comments after the presentations. So Davy, if you would please share Ms. Chowdhury's presentation. Thank you.
Hello everyone. Today I'm going to talk about my study on the impact of organizational citizenship behavior on corporate sustainability through the mediating effect of total quality management. I'm Simi Chowdhury, an MBA student from the University of Texas Rio Grande Valley, and my professor is Dr. Zhu Zheng from the University of Texas Rio Grande Valley. My study is aligned with UN Sustainability Goals, goal number 8, good jobs and economic growth. Before starting the whole presentation, I'd like to give you a short introduction to the 3 components that we have worked with in our study. So what is total quality management? Total quality management refers to strategies and management systems that improve customer satisfaction, reduce operational cost, and improve production quality, prioritizing the involvement of all managers and employees and data-based decision making. And what is organizational citizenship behavior? In industrial and organizational psychology, organizational citizenship behavior is a person's voluntary commitment within an organization or company that is not part of his or her contractual task, and it is linked to overall organizational effectiveness. Thus, this type of employee behavior have important consequences in the workplace. And what is corporate sustainability? It is an approach aiming to create long-term stakeholder value through the implementation of a business strategy that focuses on the ethical, social, environmental, cultural, and economic dimensions of doing business. These strategies are created to intend foster longevity, transparency, and proper employee development within business organizations. What we are trying to find here is, we believe that after implying that total quality management strategies, the employees will believe that they are working in an ethical environment, and they will be more likely to engage in in more positive behaviors such as organizational citizenship behavior to promote the organization's sustainability goals. So what motivates us to do this study? During this COVID-19 pandemic and the other global issues such as climate change, non-renewable resources, and environmental pollution that has surrounded all stakeholders and also impacted our daily lives. And in the business sector, the customers, they are becoming more conscious of the environmental pollution, the climate change, and diminishing natural resources. So both the parties are actually playing a sensitive role in this study. And thus, the companies are accelerating adoption of sustainability strategies and environmentally friendly practices. So what we know, when we try to find some studies on the topic that we are working here, we find out that a study from United Nations 1987, they stated that an organization is considered sustainable if it develops to meet the needs of present without compromising the ability of future generations to meet their needs. And another study from Gorek et al. 2012, we find out that they stated today's companies that ignore social responsibility will face negative impact. And we also tried to find some studies on the focus on sustainability, and we find out from Abbas 2020 paper that they stated that the focus on sustainability is not a new trend, but a focus on stakeholders or corporate performance is a new trend. And some previous studies on corporate sustainability, we find out, like Shehzad et al. 2020 paper, they mentioned about measuring CS performance in their study, and Lorenzo et al. 2020 paper, they try to focus on company reputation and employee productivity. And Eccles et al. At 2012 paper, they try to highlight employee engagement. And Lee and Ha Brookshire from 2017 and Roop et al. 2015, they try to focus on organizational citizenship behavior. So we tried to look for the elements in the study and from the papers that we find out, and these are some of the highlighted study that we'd like to share with you. What we don't know, the research gap. It's the silence in theoretical knowledge expansion of total quality management and its impact on the relationship between OCB and CS. So basically we are trying to find 4 questions here. So these 4 research questions will be finding the impacts of OCB on CS, OCB on TQM, TQM on CS, and does TQM mediating between OCB and CS. So our research model is showing 3 components from the study, OCB, TQM, and CS. And we have 4 hypotheses that we're going to test here. And the first one is OCB has a positive relationship with CS, and OCB has a positive relationship with TQM, and also TQM has a positive relationship with CS, and TQM mediates between OCB and CS. So the data collection and instrument, we collected this survey data from management of manufacturing companies in Bangladesh, and all the data have been collected on 2020. And after cleaning missing values and sampling errors, we find out the numbers were 216. All items were evaluated on a 7-point Likert scale, and where 1 is strongly disagree and 7 will be strongly agree. So OCB has 19 items which we adapted from Organ 1988 and 1990 paper, and TQM has 38 items which has been adapted from Jung and Hong to 2008 paper, and corporate sustainability has 14 items which has been adapted from Abbas 2020 paper. So in the instrument validity and reliability, so we tried to look for the validity of constructs, and in the KMO value of OCB we find out that the value of OCB will be 0.824, and TQM KMO value is 0.840, and CS KMO value is 0.696, whereas we are trying to find a KMO value greater than 0.7, and we can say that OCB and TQM is in a good shape, but CS is in the borderline. So they have a question on the CS questions in the study. So, and on the Bartlett's test, we tried to focus on the significance, and they all are coming out p-value less than 0.05. So we can say that all of them are valid. And on the reliability of constructs section, we did try to find the Cronbach's alpha value, and this alpha value we are trying to look for a value greater than 0.7, and we can see that all of them are greater than 0.7, so we can say that all of them are reliable. And on the regression and path analysis, so the regression analysis p-values are looking good because they are all of them are less than 0.05. Only in the path analysis for the OCB to sustainability p-value is kind of in the borderline because it is very sharp edge on 0.05. So we can say there are some questions on OCB to sustainability p-value. So on the resultant discussion, we can say that we find out from our research hypothesis that OCB has a positive relationship with CS, OCB has a positive relationship with TQM, and TQM has a positive relationship with CS. And finally, we can say that TQM fully mediating the relationship between OCB and CS. So the practical contribution will be the OCB alone might not be sufficient to improve sustainability, and TQM can be an excellent strategy fully mediating between OCB and CS. Lastly, I would like to thank Dr. Girwal for nominating me as a Sustainability Fellow, Dr. Jo Jung for his supervision, Ms. Franklin for her guidance, and Office of Sustainability team, and definitely my family members.
We know that Simi is not with us today because she's taking an exam, but we want to congratulate her and Dr. Zhuzheng for such a wonderful project. They worked tirelessly to get all this data from the manufacturing companies going back and forth to be able to share the valuable information that we heard today regarding OCB and TQM and its relationship to corporate sustainability, which is so important to us today. So as Simi shared, it is through TQM that we can possibly find a bigger or better connection to corporate sustainability. And again, this is information that is coming from all the extensive work and data collection that they put together. So thank you, Simi, and thank you, Dr. Zhuzheng, and we hope to hear from you, Dr. Zhuzheng. I'm not sure if you're in the audience with us this morning and this afternoon, so that we can possibly hear your experience with Simi and any added thoughts or information you might want to add to her presentation. We give our students such limited time, it's very difficult for them to share everything. We're the ones who get to hear it all through our meetings with them, and it is difficult to put it all together within 10 minutes. Next, we're going to hear from Ms. Claudia Aleman. Ms. Claudia Allman has been working on the inventory, the greenhouse gas emissions inventory of Utrgv. And there was a drastic change between our presenter last year. Last year we had another student who was working on the greenhouse gas emissions, but of course we do this on a yearly basis. This year, Ms. Aleman is going to help us understand the impact of COVID-19 as it relates to our carbon footprint. And there is a lot for us to learn from this year because of everything that happened and the drastic changes between 1 year of inventory to the next year. So we're going to hear from her, and I want to thank Dr. Jongmin Kim and Dr. Mason Pornick, who are also our faculty sustainability fellows who have been helping us. We're going on 3 years now in a row of conducting these greenhouse gas emissions with the assistance of these two faculty fellows, Dr. Kim and Dr. Pornick, with our sustainability fellow students. So these students are from engineering and they're learning how to actually do these inventories and calculate all the data that they must collect to do this. And you're going to hear just a snippet of it because again, it's just 10 minutes. So Davey, I'm going to ask you if you could please share Ms. Claudia Aleman's presentation.
Over a year ago, you would have never imagined the transition to remote work and learning. The impact that COVID-19 had on Utrgv's carbon footprint is presented. Thank you everyone for joining, and I hope you enjoy this presentation. My name is Claudia Aleman, and I graduated with my bachelor's degree in mechanical engineering in May 2019. I then began my master's degree in the middle of the pandemic. Remote learning was a huge change, not only for me, but for many. And to be honest, I do enjoy change. Not only does it allow growth, but it set me on to my engineering career path. When I was in middle school, my parents owned a car wash where I loved to help out. I would be fascinated with the cars that would arrive to be serviced. Observing the changes and improvements in technology the cars underwent intrigued me. I then decided I wanted to be a part of significant changes. Today, the world is faced with the accelerating detrimental effects of climate change. Climate change is a long-term change of Earth's overall temperature and typical weather patterns in a place, usually or mostly caused by greenhouse gas emissions. So what are greenhouse gas emissions? Well, these are gases in Earth's atmosphere that trap heat emitted from human activities, such as the burning of fossil fuels. These gases can remain in the atmosphere for many years and are measured in metric tons of carbon dioxide equivalent, MTCDE. Basically, all major greenhouse gas emissions released are converted to the equivalent amount of carbon dioxide, which is considered the most concerning greenhouse gas. Now I introduce Utrgv's greenhouse gas emission inventory, which was created as a strategic plan to set a baseline of overall campus resource use, as well as to answer global requests and track and reduce greenhouse gas emissions and achieve greater sustainability on campus. The greenhouse gas inventory allowed results analysis of carbon footprint on campus for fiscal year 2020. This sustainability project is based on goal number 12 and 13, which aim for responsible consumption and production, as well as climate change by the year 2030. Reports of the COVID-19 pandemic spreading originated in November 2019, but officially impacted Utrgv in March 2020. Nearly half of fiscal year 2020 emissions was impacted by COVID. The methodology behind the data collection is the following. Scope 1 includes owned or controlled sources by Utrgv. Scope 2 is purely from the generation of electricity. And lastly, Scope 3 is from sources not directly controlled by Utrgv. As the scopes increase, it does become much more difficult to control and mitigate. Fiscal years range from September 1st through August 31st. So basically, all the resources used by the university within that time frame are accounted for in the inventory. The map shows Utrgv's campuses and off-campus research and teaching sites throughout the Rio Grande Valley. As a growing institution, Utrgv has increased in space by 7% and in enrollment by 10% since the baseline year, which is fiscal year 2016. The following graph shows the number of resources consumed versus the fiscal year. Although there have been an increase in university fleet due to the merge of two campuses that are miles apart, a 19% decrease in fleet fuel was due to a complete stop in bus routes after COVID. University sports were paused with unoccupied soccer fields, causing a 10% decrease of synthetic fertilizer application. Lastly, with less demand in campus buildings, refrigerants and fossil fuels decreased by 29% and 9% respectively. In Scope 2, electricity consumption showed a steady situation. Although the campus went remote, buildings still had to operate at a smaller level due to future possible maintenance issues. Considering the addition of space and enrollment, as well as Utrgv's focus on operating in a more effective and efficient way, the efforts to control and mitigate electrical consumption have shown to be quite impressive throughout the fiscal year. Finally, the most difficult scope to control and mitigate proved to be the most impacted by COVID. When the campus went remote, a total of 12 waste containers were not utilized, allowing landfill waste to decrease by 38%. Travel bans across the world restricted air and ground travel. Wastewater was the only category that produced an increase, likely driven by more hand washing and cleanliness standards with COVID-19. Also, due to a decrease in fertilizer consumption, fields were watered more often. Less commuting to and from school caused a shift in commuting habits. A commuting survey was sent out in fall 2020 to obtain more accurate information on the mode of transportation used by campus users. With a shift to remote learning, carbon-free commuting went from 13% to almost 50%. The total resource consumption in 2020 was used to determine that 69,800 metric tons of carbon dioxide equivalent were emitted, a decrease of 18% from fiscal year 2019. The overall campus footprint was then normalized to further understand how a campus user or the area of building contributed to the total campus emissions. It was calculated that 2.9 metric tons of carbon dioxide equivalent was emitted per full-time campus user. So whether you were an employee or a student. Focus on energy-intensive spaces such as laboratory space, healthcare space, and others resulted in 16 metric tons of carbon dioxide equivalent emitted for every 1,000 square feet on campus. So this study allowed us to track the reduction of greenhouse gas emissions and what was a turning point in this data collection for future mitigation to protect the planet. With future emission mitigation, air quality will not worsen, which benefits human health. And lastly, the reduction of greenhouse gas emissions due to COVID saved Utrgv $82,723 in electricity cost, $106,347 in fossil fuel costs, and $79,828 in paper purchasing cost in comparison to the previous fiscal year. Students and employees also benefited by saving gas costs from less commuting. Reduction strategies have already been implemented at Utrgv over the past years. Opportunity to further grow can help control or mitigate greenhouse gas emissions. This inventory proved that the most difficult scope to mitigate was the most impacted by COVID. As we considered coming back to a new normal, continuing to offer remote or hybrid learning could further progress mitigation in Scope 3. Utrgv currently accounts for over 100 electric vehicles that mitigate Scope 1 emissions. Continuation in these initiatives could be significant. Aside from the solar energy already incorporating in the engineering building and in conjunction with SpaceX, expansion of renewable resource energy on intensive buildings emissions could improve Scope 2 emissions. This research has provided a roadmap for Utrgv to further advance towards their sustainability goals. Acknowledgements. I want to thank Dr. Graywall for giving me the opportunity to become a sustainability fellow. This project left me with valuable skills and insights on sustainability. Thank you also to the Graduate College and Office for Sustainability for awarding me this fellowship. A special thanks to Marianela Franklin, who is my sustainability mentor. With her help and guidance, I learned a lot about sustainability and developed better research skills. The completion of this project would not have been possible without the support of my advisors, Dr. Pornick and Dr. Kim. And lastly, I want to extend my gratitude to the Facilities Planning and Operation Department, the Accounting Department, the Transportation Department, and the Assets Management Department for collaboration in data collection.
So I hope you were just as impressed as we were when we saw Ms. Claudia Aleman's presentation. It is very valuable to understand how we measure these greenhouse gas emissions and to be able to see the differences between one year and the next. And for her to collect all this data and be able to share with us just where those reductions were and why they happened and how we can possibly behave differently as we move forward is extremely important for us. And we want to thank her and Dr. Pornick and Dr. Kim for doing such an amazing job. Again, we invite you to visit with them to see the full report. It has a lot more detail than what you heard today, and it is quite impressive to see that full report. We will be sharing it on our websites, so we hope that you will take the time to review these reports. Again, thank you so much, Claudia and Dr. Pornick and Dr. Kim. We hope to hear from you. I'm hopeful that one of you, at least one of you, is here with us today to be able to answer any questions or provide comments in a little bit. Next, we're going to go to Mr. Eric Martinez, who also is working on a very important project, which is flow simulation for a novel wave energy converter. I am eager to hear from him as well as from his advisor, Dr. Yingshen Yang, because they waited quite some time to be able to use this system. They needed approval to use this very high-class system, basically high-class computer out at UT Austin, which they just recently received. So we may not get the results of the modeling that they did with this new computer, but we do hope to go back to Eric next semester so that he can share even more. But they did some really impressive work as well in looking at a new way to simulate and to look at wave energy converters. This is another form of renewable energy. For those of you who are not engineers, if you know a little bit about Nikola Tesla, who invented these motors that are under Niagara Falls, that with the motion of water create energy. This is, I'm just giving you a really probably a bad analogy, but an analogy of what a wave energy converter is and how Mr. Eric Martinez and Dr. Yingshen Yang have worked on this to improve what we know today as wave energy converters. So I want to thank them both. And Davey, if you could please share this presentation, I think everyone will be highly impressed with this one as well. Thank you.
Hi, good morning. My name is Eric Daniel Martinez, and I will be presenting on the flow simulation on a novel wave energy converter design. It is an understatement to say that humans have made great technological leaps throughout the ages, but with these leaps, we have reached a point of massive energy consumption. Energy consumption that unfortunately we can no longer live without. Oil and gas have become our main source for this energy, which has led to our planet suffering in its wildlife, environments, and negatively impacting the climate overall. The most terrifying thing about relying so strongly on oil and gas despite its harm is that we have a ticking clock against us, since these resources are limited. At the rate we are going, we will be depleting our fossil fuels by 2060, only 40 years away. Now, engineers, scientists, environmentalists have observed this imminent threat and come up with a solution: renewable energy. Renewable energy is energy that can be harvested from sources that either do not need human intervention to replenish or that will basically never run out. Examples of this are wind, hydro, solar, geothermal, and biomass energy sources. Currently, the transition has been successfully begun, with solar and wind power leading the race. Now, when you think of solar or wind power, you might have a clear idea or a clear picture of what that looks like, because there is already a good enough design that people are either trying to replicate or trying to improve on. Now, we are trying to further bring wave energy to the limelight as a strong contributor to renewable energy globally. Wave energy is still at a stage where everyone is competing to have the one design that is drawn in everyone's minds when they hear it. And as you can see, all of these wave energy converter designs are very different from each other. Now, wave energy holds a much higher power density compared to wind and solar, which have 1 kilowatt per meter each. On top of this, there are always waves in motion in our oceans, compared to the sun, which is not always available due to the day and night cycle, and wind, which is variable in its intensity. It holds great advantages, and with enough implementation, wave energy could become the major contributor to the power grid in the near future. Now, our ocean is a vast, rich part of our world, with about 71% of the Earth's surface covered by this great blue. It is a source of food due to the fishing industry, tourism due to the beautiful beaches around the world, and it even helps our own existence due to the phytoplankton that provide 50% of the oxygen in the planet. The ocean has provided us with numerous gifts since early humanity, and we have learned to harvest its resources. However, with our many technological advancements, we are still due on the task of extracting energy from the ocean successfully. Many efforts have been made into designing the most successful wave energy converter, or WEC as they are also called, especially in Europe, since you can see here there is a high power density available for the European oceans. However, our research team at the University of Texas Rio Grande Valley wishes to become a part in this effort to develop the best WEC design. My name is Eric Martinez, and I have been interested in fluid mechanics since the early onset of my undergraduate career. And I work alongside Dr. Yingchen Yang in the Mechanical Engineering Department and Dr. Ven Xu from Mississippi State University. Through my graduate studies, I have found an immense passion in sustainability and helping save our planet with the help of engineering design. Now, usually, WEC designs take years to even make it to ocean testing, which not all of them even do. Now, that is if they even get there, like I mentioned. All WEC designs look different from each other. However, our team is confident in our design, being the first unidirectional wave energy converter. Most wave energy converters offer very complex designs, composed of controllers that adjust to for the WEC to work with any wave frequency. Since also most WECs work on something called the resonance principle, where the WECs are designed around a specific wave frequency. However, as you may imagine, the ocean is very chaotic, random, composed of multiple frequencies, and as such, the idea of designing around a single one of them turns into an inefficient design. Our design is robust, simple, and modular in the way that it allows for waveform configurations that can be easily installed, maintained, replaced, and uninstalled if needed. Our WEC is composed of two rotor sets, one vertical and one horizontal, with blades with hydrofoil cross sections, which looks similar to a wind turbine cross section or an airplane wing as well. Now, the orientation of the rotor sets will allow the wave energy converter to rotate to a single direction no matter the direction or frequency of the waves that it encounters in its lifetime at sea. This makes it a WEC that is able to work with omnidirectional waves. Now, although we are years away from even building a full-size prototype, we are interested in studying how this WEC design might perform under different ocean conditions. Now, we can do this with something called computational fluid dynamics, which is a tool that engineers use since the age of computers has been getting more and more powerful. Now, computational fluid dynamics, or CFD, is a science that uses computational power to predict fluid flow phenomena. These simulations can help predict phenomena that is extremely difficult or almost impossible to obtain experimentally. They are used in aerospace, automotive, marine, HVAC, batteries, and many more areas of science and engineering research. Now, these simulations take place by solving sets of very complicated partial differential equations multiple times in a domain that is divided into very small sections known as a mesh. Now, each of these triangles or prisms or cubes are called cells, and all of them put together are what is known as a mesh. Now, by breaking down the problem into multiple smaller sections, you are able to solve each section individually. Now, each of these cells has their own mathematical equations that are solved with Navier-Stokes equations. The solutions of one cell feed into the next, and that one also has its equation solved, and so on until the entire domain has a complete solution. Now, simple simulations can be performed with any computer, but with the more cells, the longer your simulation takes to compute, since there are more equations to solve. However, the more cells you have, the more accurate your solution is going to be as well. Now, due to this, supercomputers are often used for these research efforts. In our case, we were honored to have collaborated with the Texas Advanced Computing Center, which is an internationally renowned supercomputer directed by UT Austin, ranking in the top 10 most powerful supercomputers globally. Now, here's an example of what our simulation looks like. For our simulation, we set up a virtual wave tank with real waves, of which we can control anything from depth, frequency, amplitude, etc. The simulation can provide us with valuable data that can help improve and better understand our design and the phenomena that happens around it, such as velocity fields, pressure points for low pressure or high pressure, rotational speed, and torque, which can be used to calculate the power the wave energy converter is extracting at any point in time. We tested different design parameters, such as the thickness of the blades, length, angle, etc., and we obtained a comparison to which design provides the highest power. Here in this case, we ended up selecting the NACA 0030 since it provided the highest average power compared to all the other ones. We also tested different frictions, which emulates the presence of an electricity generator that makes the WEC rotate slower in exchange for the mechanical energy being transformed into electricity. Now here's a comparison of what it looks like without any resistance and with the friction added. As you can see on the left, the WEC rotates faster and faster as it winds up, whereas on the right, it is more controlled. However, by restricting the rotation, you end up being able to harvest that energy like you want. And by testing different frictions, we were able to select our peak power friction, which was about 0.125 for the friction coefficient, which is what we are going to be using for all of our incoming simulations. Now, these simulations exhibit low power due to the size of the model, which is 4 times smaller as the full size would be and is not encountering the same amplitude or periods of the waves that it would encounter in the ocean, since it is at a smaller scale. Now at that point, it is going to extract far more energy once it is taken into that full-scale model. At this stage, we are completed with our WEC design parameters, and we will go into testing different wave configurations to build a power matrix that tells the story of how the WEC will behave under many different height frequency configurations. Now, while our work is going to continue testing different conditions, we are very hopeful that the simplicity of our design will put us ahead in the race towards the best WEC design. We hope that these simulations and design optimization efforts can lead into a full-scale model that can become internationally recognized for its advantages offered. We are very happy to have worked all up until this point, and we are excited for all the work that is to come from learning more about our design and taking it to full completion. We want to express our thanks to the Sustainability Fellowship as a whole for the support of Ms. Marinella Franklin, Dr. Parvinder Grewal, and the Texas Advanced Computing Center for collaborating with our project. All of these have allowed these research efforts to continue strongly toward our goals. And if there are any questions about the project, or if you have any interest in wave energy or CFD, I would love to get in touch with you. And thank you very much for listening, and I would like to open the floor for questions. Thank you.
Isn't that just so impressive? Thank you so much, Eric and Dr. Yingsheng Yang. This project has been one that we've been watching really closely and that we're really excited about, and we can't wait to hear more. That concludes the 3 presentations that we have for today. We also have another fellow, Ms. Anita Narayanan. She had some technical difficulties, so we will be adding her presentation after the fact, and we hope that when we send out the link of the recording of this presentation, it will allow you to go back and hear all these wonderful presentations over again, but also so that you can hear and watch Ms. Anita Narayanan's presentation on 3D printing of embedded sensors, pushing the limits. I apologize, my sensor is very sensitive. 3D printing of embedded sensors, pushing the limits of commercial off-the-shelf sensors. So she also has an amazing project to share with you all, and we can't wait to send that out to you. And we apologize that with the technical difficulties, we weren't able to get her presentation to work, but we will share that here in the near future. With that, I'd like to again ask every one of you to please provide any questions or comments. We're going to ask you to please raise your hands so that you can be unmuted and so that you can either ask a question or a comment. We will begin with Mr. Jeremy San Miguel, and I apologize, I did not introduce him in the beginning. Mr. Jeremy San Miguel joined our office this semester and has been working very closely with our fellows. So I'm going to ask Jeremy if he has anything he'd like to share about his experience with these wonderful fellows.
Thank you so much. I absolutely would love to. So first, I'd just like to say, wow, it is so honoring to see all of your works come to fruition. Now, to our graduating fellows, you all have done superlative. Your time spent committed to your research, to sustainability, and to your education overall. It really showcases in what you presented today. I believe you really left like a remarkable staple and wisdom to our remaining fellows and those yet to come. And it's just been truly honoring. Thank you.
Thank you, Jeremy. Was there anyone who wanted to also add? I know that we have a couple of our faculty advisors with us. We would love to hear from you and the experience you've had with these wonderful fellows.
We also have two of our fellows with us now too. We have Eric and we also have Simi.
Oh, wonderful, wonderful. So Eric or Simi, anything you'd like to add?
Let's go ahead and.
Hi. Yes, I just wanted to express my gratitude for the entire program and my congratulations to the other fellows as well for making it through this journey. It's been really great to work with the office.
Thank you, Eric. And we're so very proud of you. This work is just so impressive. It's so remarkable, so incredible. We can't wait to hear the end result. You know, I know that you didn't have enough time to finish your project because, of course, you know, this is ongoing for you, but we hope that you will stay connected and continue sharing with us.
Of course, I will definitely keep everyone updated on the final result of the project.
Yeah. And personally, I can't wait to have my entire home powered by waves.
That would be wonderful.
Yes.
Hi.
Hello.
Hi. I would like to express my sincere thanks to the whole sustainability team for giving me the opportunity to work on such a wonderful project. And I would like to also wish all the other fellows for their future projects. And I hope they succeed. Thank you so much.
Thank you, Simi. We really enjoyed working with you, and your presentation was very, very impressive. I know it was quite technical, and for some people, they may have not gotten the whole gist of it, but as I mentioned, we will be sharing those reports within our own within our website, and we'll be sending you links to all of this. So we hope that you will connect with us to continue to review the work of our very talented and very remarkable fellows. So thank you so much. I think we have Marianne with us as well. Marianne is another one of our fellows that just started with us this semester. Did you want to say something, Marianne?
Yes. Hello, everyone. So I know how much of a work our research comes with, and I would like to say congratulations to all the fellows who just presented. I mean, they've done extremely well. Yeah, and I hope I also am able to excel like they have. Yeah, thank you.
Thank you. Yes, we want to congratulate them all. I want to provide this opportunity. I know Dr. Graywall had mentioned he wanted to provide some remarks after he saw the presentations. And so if we don't have any faculty advisors who would like to provide comments, I'd like to provide this time to Dr. Graywall to share, you know, his comments regarding these presentations and the current fellows who are our graduating cohort.
Yeah, I'll wait if any faculty member want to say anything.
Hi, Dr. Kim.
Yeah.
Oh, yeah. Can you hear me?
Yes,
Sure.
yes. How are you?
Okay, great. Yeah. Oh, I'm so impressed by the works that the fellows did, and it's very impressive to me. And especially, I worked with Miss Aleman, and she worked on this campus carbon credit project tirelessly. And me and my colleague, Dr. Pernick, so impressed by her thorough and professional work. Especially, it's great to understand that what's happening on campus in terms of carbon, carbon emission and such. And it's also very, very impressive work by giving us the snapshot of what happened during this COVID time. And it seems like we're going at the right direction overall the campus, and I really thank Ms. Aleman for working on this project and giving us the very great understanding of situation that's going on. Also, I really thank Marinella and folks in the sustainability office, because without them it was not really possible. Also, I really thank Dr. Gruel as well for giving us the opportunity. But above all, I really congratulate Ms. Allman and other fellows who has done very, very impressive work on the overall sustainability work. And that's all I have.
Thank you so much, Dr. Kim.
Thank you. Anyone else? Okay, thank you. From my perspective, I want to follow Jeremy on this as well. This is a tremendous work. It's amazing what small investment can do in terms of producing new research, putting Utrgv on the world map. It is kind of making Utrgv a sustainability leader through these small projects. It is tremendous dedication from the students and their faculty members who have guided them through this new research. All three projects are impressive, cutting-edge new research. And this is what we like to see. And the students have delivered that under the mentorship of their faculty. And our sustainability program, Marinella and Jeremy and others that help these students accomplish their goals and keep them on track in terms of making sure that all sustainability development goals are hit by their research, whatever is applicable. So this is just amazing. So Simi's work demonstrates that total quality management mediates sustainability, that is the corporate sustainability, and the organizational citizen behavior. This is total quality management from the management of the organization perspective, and that helps them learning about what the client wants and how they can actually be responsive to the client and deliver on what they want. And in the end, what you are seeing is that people are more motivated within the company to do more sustainability type work and articulate that what they are doing so that they can be more profitable and more sustainable. So thank you, Simi and Professor Young for doing that work. Claudia Allman, what can I say? This is the work that we do every year, and the students that participate under the mentorship of our two faculty, Dr. Kim and Pornek, it is very, very hard work that every year they have to collect so much data and continuously work with the multiple stakeholders within the university. And they are able to build that relationship with everyone and collect that information. And showing that COVID had an impact. We heard about that early on, that there is this less polluted layer around the earth during 2020 because of less transportation, less flights, and all of that, as we heard, right? Here is evidence in our home, in our backyard, at Utrgv campuses. This data shows that that is actually true. So we not only reduced environmental, greenhouse gases, but we also saved some dollars. I hope that we will not return to status quo after COVID-19. We would be seeing overall reduction in gas emissions and the cost associated with the energy consumption that we normally have. So congratulations to Claudia and their professors for showing this. And I'm hoping that they will be able to publish this work. And this is really wonderful. Okay, and the last project, Eric Martinez. This is another groundbreaking project to me. This new design that they have come up with, I hope Dr. Yang is with us, Eric is with us. I hope they have patented the design and the simulations. I'm really sorry to hear that they have to wait so long to get the data analyzed. But to that point, we are establishing a high performance computing center at Utrgv through two separate grants, one from Department of Defense and one from National Science Foundation. Faculty have gotten this money to establish a new high performance computing center that's based on GPUs. So hopefully newer students would be able to use that, as this center should be up and running in next semester. So congratulations on that. I hope this becomes the future where lots of energy could be again freely used from natural phenomena, just like wind and sun. So with that, I want to also take this opportunity to thank again Marinella and her group for supporting these students. I'm impressed that how these students grow in just a short period of time in thinking about sustainability from all perspectives. As you know, she always talks about all three components of sustainability, right? It's not just the environment, it's economic, it is social. So she always talks about all of that. And this is evident in all three presentations here today. So I appreciate all the hard work that unit does. And faculty, without faculty support, nothing could happen, right? Students would try to do their work as much as they can. Yes, some would succeed, some would not succeed. But it is the faculty's commitment and guidance that these students are able to make progress far more rapidly and be able to publish their work as well. So thank you, all those faculty who have taken the initiative and also nominating these students so that we could consider them for sustainability fellowships. We are now getting many more fellowship requests. We don't have that much money, but we are trying to find more. So hopefully we will continue this program and continue to expand this program so that more and more students can get the benefit from this. So congratulations again to the students and to the sustainability program and all the faculty and students.
Thank you so much, Dr. Gray. Well, you know, this is an extraordinary program that would have never been possible without your support, without you establishing this amazing program. And with that, I don't want anyone to leave just yet because I want to introduce you. As Dr. Graywell mentioned, we have had a lot of applications. So I want to introduce you to the students that the current fellows we have now that you'll be hearing from next semester, and also share with you the students that were just awarded for spring 2022. We want to congratulate them. I'm going to go fairly quickly through these slides because I want to introduce you to the current cohort. Mr. Ashrafussaman Nassim is in the Disaster Studies program, and he is working on a project called Community-Based Evacuation Preparedness. I apologize for the typo. Community-Based Evacuation Preparedness Plan for Decision-Making, one step further to hurricane resilient community in the Rio Grande Valley. So this is really, really important work. I hope you will join us next semester to see his work. Also, another wonderful fellow, Ms. Shaila Akhter-Shetu. She is working on design synthesis and in silico validation of new anti-cancer compounds. So please look forward to watching and listening to her final report and presentation on her research. Ms. Mary Ann Blagoji, who you heard earlier, she is promoting best sustainable transportation practices for economic development with the research focus in Hidalgo County. So we look forward to hearing her presentation. Ms. Denise Salcedo, she is integrating Latino indigenous healing practices to Western psychotherapy model. So this is where, you know, we start to hear from cultural healing, cultural medicine, and how that can be incorporated into psychotherapy models, Western psychotherapy models. Ms. Catherine Muriyuki, who is working on financial literacy models with a completely different perspective than we've seen in the past. We've normally seen financial literacy models from the perspective of our College of Business and our economists. Ms. Catherine Muriyuki is coming from the social side and focusing on international student financial literacy. So we look forward to hearing her presentation as well. Ms. Kimberly Regalado, promoting sustainable development and preventing language loss in the Valley to preserve culture, high quality of life, and education. Really excited about her project too. Ms. Judith Anani, analysis on the chemical compound of camu camu and its potential benefits to cancer treatment. And we also have Ms. Dipashri Bomik. She is working on sustainable nanofibers in a medical application. She's looking at those nanofibers for the sake of medical applications. And last but not least, Mr. Salomon Loredo, who will continue the work of Claudia Aleman, but now looking at the greenhouse gas emissions inventory for this next fiscal year. And so we look forward to seeing what, you know, the continuation and what is occurring now that we're back on campus. What is the fluctuation? We learn from all this, as Dr. Graywall said. It helps us understand our behaviors, and it helps us understand where we can make these changes to help reduce our carbon footprint. So thank you to all of those wonderful fellows, and we want to congratulate the new fellows that were just awarded for spring. Sudita Ashrahi, Kim David Kuma, Saul Lopez, Integab Allah, Vivas Batacharji, Tanmoy, and Mohammed, Tauhidul Islam, Adriana Castillo Melendez, and Hillary Abiagon. We're really excited to have you. We can't wait next semester to meet you and to start working with you on your projects. That concludes our presentation today. We want to congratulate everyone. I believe Dr. Graywall has already provided his closing remarks. I don't know if there's anything you'd like to add, Dr. Graywall. We're just so very proud of all of our fellows and so excited to hear from all our current fellows next semester. And we really just want to thank you for joining us and thank you for participating in this incredible program. And we hope Dr. Graywall can find more funding so we can get more fellows, because we really enjoy working with all these students. It's always so inspiring. They are so talented and so committed. You know, our students are very gifted, and we see the promising leaders of the future in all of our fellows. So we hope that you will join us, each semester as we celebrate and we listen to the wonderful projects that each of our fellows has to present. Dr. Graywall, if there's anything you'd like to add.
Oh, thank you. I second what you said and appreciate everyone's work. Thank you. Have wonderful holidays and congratulations to all the students who are going to be even graduating. So go Vaqueros.
Go Vaqueros, V's up, and thank you all fellows, advisors, department collaborators, and consultants for your dedication, commitment, and your continued support. We are very, very honored and privileged to receive the support of all of you, and we hope to continue that as the years come by. And happy holidays to all. Thank you, and have a good afternoon.